Alrighty guys, so today we're going to be going over post tension overlay that we did. So it's a tennis court, and basically what was going on is, as you can see, there's all these cracks, and this was an asphalt court, so the cracks just kept getting bigger and bigger. And the surface was actually carpet. So what happens with carpet is that the surfacing itself is carpet. There's the asphalt, which is the surface underneath, but then this itself is carpet. So where it starts cracking, the carpet starts lifting up, like peeling up, kind of like anything that peels, like an orange peel, you know. So basically, when you can patch the cracks, but they'll just open right back up because the surface is actually peeling off. So I mean, the patch material doesn't really stay. So here's another look at the, damn, what's going on over here? Here's another look at the cracks so we could zoom in. And some of the cracks were actually pretty substantial. Like you could fit a whole car key all the way down since all the way to the depth of the asphalt itself because the asphalt was really just breaking down. So these cracks don't look too big from here, but if you look at them vertically from the top, they're pretty big and pretty deep. So they were definitely structural. And like I said, we weren't really able to patch and repair and resurface this because it was carpet. So the other solution that could have happened here is to remove all the carpet and then patch up the asphalt, but the asphalt surface was already really rough and broken down as is since I lifted up some of the carpet and removed it to see. So that would have to been a whole nother surface preparation, and I mean, it just wasn't really worth it. So it was just better to put a brand new post tension system over it. So anyway, so the overlay, what it consists of is we marked out this basically since we're gonna put in a post tension slab over this, and there's walls around here. This wall, on all four corners there's walls. So we need to, since we're when you put a post tension system over it, you need to pull the post tension cables, and you need space for that. So basically, what we did is remove the edges of the court all around, uh, about 14 inches wide on the sides that do not have the cables. Two sides are where the cables are going to be pulled from, this side and this side, since the cables run this way, this whole way. Post tension cable is going along, and then post tension cable is going this way. And you need two ends where you can pull them this way, so from over here, and then pull these this way from over here, and then tighten them up after you pour the slab. So we remove the perimeter, about 14 inches wide, and we remove all this. So we marked it out so we could saw cut it, then break it out and remove it, and that gives us our turn down and also our space to pull the post tension cables. So that was the first step. Now we also wanted to put in some new posts. So this is where the old posts were. As you can see, we saw cut the square, and inside the asphalt, what there actually is a concrete footing for the posts. So I just wanted to put new post in and just remove the old footing. And so we went ahead and did that. So removed the old post and its full footing. And then also over here you can see the socket guy socketing that those white lines that we saw previously that were marked. Another thing we had to consider for this job was that we were going to elevate the whole slab by 5 inches because of the post tension system going over this. So we had to kind of ramp it down. So we had to kind of ramp this down so that it could ramp down. And since we're elevating this is going to be 5 inches taller than this existing slab on the outside of the court for the entrance. And there's also a drain that we had to make sure we kept in mind when building the new court. So basically, from the drain inwards, it goes up to 5 inches. Um, and then right here it slopes down a little, like a few inches down from the actual court, so that it could drain down here. And then from the drain onwards to the existing slab on the entrance, we actually just ramped it down like a ramp. So it could be at level with that existing slab on the outside. Here again is the stock hut area. As you can see kind of these empty lines on the white line. That's because we held the string line and then just came around with white paint and marked it out for the socket guy. And now here, this is the area that was socket. Um, you can see, um, basically we removed this area as well, but first we removed this socket area itself. So you can see it's been socket, and then we just kind of hit it with the sledgehammer, break that asphalt apart, and then lift it from the bottom of the asphalt right here with the pickaxe, and removed it manually, threw it in some wheelbarrows, and took it out. We went for the bobcat to lift these things up easier with the forks, but by the time we came back, the guys had already removed it all by hand. And then here are the post tension cables. This is how they go. Like I mentioned, they're lined up from one end to the other, and then from the other end to the other. So 120 feet this way, and then 120 feet that this other way for each cable. After the concrete is poured, they're pre-stressed the day after. Just I'm not sure how much PSI they put the first day, not too much. After about a week, then it's 2,500 PSI tension on each cable, so that it all pulls the whole concrete together towards compressing it, because concrete is really good at compression but really bad at tension. So here, we have it formed up. We have the cables coming out. So this is why we needed to remove that edge and have that free space to be able to pull the cable. So they're pulled from this end with a hydraulic jack, and they're pulled out, and they come out a little bit more. So you want to make sure you have that slack to be able to pull that cable out. And then here we have the ramp that we were talking about from the edge of the so this is the inside of the court, and this is the drain space. So what we have here is a form, and then we have some foam, another form, and then this right here, we have our expansion joint, and then this piece of wood, it it doesn't actually go all the way down. It's pretty thin. So imagine if for example, this red piece of wood, right? If I were to flip it on its face, it would kind of look like this, pretty wide. And then this little piece of wood, if I were to, flip it around the same way, it's just as thick from all four corners. It's pretty thin. So it's just actually at the top of the concrete, at the top of the form, I mean, so that basically it under it, that piece of wood is not there. It's only at the top. So meaning when we remove this form, because we'll remove this whole thing afterwards, after it's poured, you kind of have the concrete, a little concrete square, like 90-degree angle from both sides, where the drain could sit on top of that concrete. So this is where the drain goes. It's still even deeper down here where the existing drain was, the existing drain canal. And now it's going to be even 5 inches higher because of the new slab that's going in, so that's better for the drain. It gives him more space, so it won't get clogged or whatever. But yeah, basically this piece of wood represents that, this piece of wood represents that. And basically once you remove those pieces of wood, then you have that 90 degree inwards shape, so that the drain sits on top of that and it just hovers over that, if that makes sense. That's where it gets assembled. And then here, this was actually pretty hard to form itself, because we have the whole forms, and then um, lining these little pieces of wood. As you can see, there's nothing on the bottom of them. How I mentioned they were really skinny. It's pretty hard. It was pretty hard to keep that leveled because that has to be really well leveled because it's where the drain sits on top of that little angle. So we just had to make sure it was super straight with a string line under it and looking at it and seeing that it looked really straight, And then we also have these other pieces of wood. So as the way we're gonna pour it is we would pour some concrete here and then concrete over here with the line pump. And then we'd be start removing these pieces of wood as we kept doing that. So fill this side, remove these pieces of wood, this side, remove these pieces of wood, so that it's getting compressed evenly from both sides, the form as the concrete gets poured. Okay, so by this point we had already poured the concrete slab, and sometimes people wonder, when customers wonder why concrete looks like it has marks, like after you pour it, basically we put a polystyrene tarp over it to let it cure for a while. So it kind of where the water kind of sits and there's like some um, folds on the tarp, then it'll leave lines like this of water. The water's like concentrating here, running down. Basically, the reason we put the tarp over it is so it could cure out better and not dry out too quick. Remember, concrete, when it hardens, it's the hydration process of the concrete, which is the chemical reaction that happens with concrete where it hydrates. Basically, it grabs that water and then that's what causes the chemical reaction. Um, and it needs to stay hydrated for quite a few days. I mean, probably if you could leave the tarp on it for at least 5 days, so it could the hydration process could take um, place really well and it could harden really well. Um, Usually during the first day is when concrete has the strongest hydration process and it even creates a lot of heat as it does that, but usually industry standards are 28 days, 31 days for the concrete to have its full strength. Um, and that's just making sure that all the molecules of water go inside all of the concrete and it all gets hydrated evenly. Um, but usually concrete is so much efficient nowadays. I mean, that's a really old standard and it usually reaches its full strength within even 15 days or less. But you always want to make sure you adhere to that industry standard and just let it harden. So it's really important. Water, keeping it moist for the first week, really important for the hydration process to make sure the water is hitting every little spot within the slab so that it could harden in the inside as well. Okay, so here as well, we could see the slab. This is the edge of the slab. We have this formed out as we mentioned. That's for the drain. And then we have this rebar. So this rebar here was placed as the concrete was poured. So this cured out with the concrete itself. The rebar it just hardened in there. And then these other rebars we just kind of we drilled some holes with a bulldog hammer drill, and then uh, through these rebars in here. The reason they're crooked, it doesn't really matter. It's still gonna grab on. Some go this way, some go the other way. It's because the hammer drill I wasn't able to fit it completely in there. It was a half of an inch bit, and it was pretty long. I mean, it was probably like this long plus the hammer drill. It went all the way out here, so I didn't have enough space to drill in, so I had to kind of drill in at an angle. And as I drilled more in, I would straighten it out as much as I could. But the angle of it's not going to affect it. The rebar's still rived, all these little rivs, this little texture, so it'll grab onto the concrete right. Here's just a zoomed in view of the rebar going in at an angle. Here are the existing drains. So what we are actually gonna do with them at this time, we're not finished with the project yet. We still have to pour the pour back. But we're gonna pressure wash this, make it nice and clean, and we're gonna paint it with some Rust-Oleum so we can make it look nice and new. Remember, it's 120 feet of these metal drains. And here is where the drain ends. So it ends at the corner and it goes under this wall and it exits the canal right under it. Um, on the other side, we don't have a drain. We just have the expansion joint. Um, this expansion joint, um, it's because concrete expands and contracts with temperature. So it's nice and cushiony, and it'll allow the concrete slab to uh, expand and compress and expand with temperature. But with the post tension cables, it doesn't do that as much, but still, I mean, the material itself is going to expand and contract the concrete. So you just want to make sure you have some expansion joints at the ends where it's connecting to a wall or some other type of edge. Then here we have the post, um, the sleeve of the post that goes in. So this is also has a footer in it, and this is just the sleeve where the post slides in and slides out. So it's basically a steel cylinder where that's has a bigger diameter than the net post, and it just slides in and slides out. Over here you have my boots. Now I'm just playing. Over here you have the stairs on the opposite side of the drain, and this step, as you can see, goes level with the slab. So we drilled some holes. You can kind of see them. There's one right here. There's another one over here. And basically we're gonna have some vertical rebar coming out of there, so that we're gonna pour this piece of concrete in as well to level it off with this stair and hold that piece of concrete nice and sturdy with the existing concrete stairs. Just took a Snapchat when I was doing this, but basically concrete goes on this side and then the drain in the middle as we had already gone over. Hey guys, so now I'm just gonna put a few videos of that I took at the job site, just random videos of working the concrete and just random things. So for the next video, it'll be a lot more organized and uh, better put together, but just gonna throw that in there.
Another reason why this couldn't be repaired is because this is carpet and it's basically failing, so it's not being adhesive anymore. So even if we were to patch the crack and resurface it, we wouldn't be able to resurface it because you would need to remove the whole carpet off, and then you would basically need to give a whole new surface to the asphalt that's already kind of decaying. So it's not really repairable. That's why it needs a new carpet.